Good evening, ma'am.
Good evening. We'll be starting in 2-3 minutes. Okay. Let's start.
Yes, ma'am.
Yeah. So I have my screen is visible.
Yes, ma'am.
So the first question is, what is size enlargement and why is it important? So from the lecture only you have understood that what is size enlargement, and this is the process of making smaller particles together to form a larger mass, right?
Yes,
So the important, what are other importance? So the first one is reducing cake and lump formation. So if all the particles are very small, of small size, then they will always try to be together, or that is how they create a lump. So that will be difficult for an industrial process to run. So if we enlarge their sizes, it will be easily handleable. Second one is the creation of non-segregating mixtures. Third one is the to improve flow properties. Fourth one is the to improve product appearance. Fifth one is the to control porosity, hardness, etc. So there are some other also, but on five, I have written five here. So remember this thing. Next question. What is the size range of agglomeration in food industry applications? What is the size range of agglomeration in food industry applications?
0.22 mm.
Yes. So this is answer B. 0.2 to 2 millimeter. Next question. Iron ore is preferred in the form of pellets rather than particles. Is it true or false?
And pellets rather than.
Iron ore is preferred in the form of pellets rather than particles. Is it true or false?
Mm, I don't
The answer is true.
know.
So if the iron ores are in the form of particles, what will happen? They will tightly pack and restrict the flow in the furnace or anywhere else. That is why they are used in the form of pellets. Next,
Okay.
how is dust-free and easily handleable granular product formed? How is dust-free and easily handleable granular product formed? So it is written that size enlargement through wet agglomeration and post-treatment is used to combine metal or metal-bearing powders by dry mixing to yield formulated alloying components for the final product to become a dust-free and easily handleable granular. That means first we are doing the wet agglomeration and we are doing some post-treatment like cleaning and removing the metal or metal bearing powders by a blower or something fan, and then we yielding it to formulate alloying components. That is our final product, and that is how we are creating a dust free and easily handleable granular product. Next question. What is the advantage of fertilizer granulation? What is the advantage of fertilizer granulation? So if we do fertilizer granulation, that will help in product freedom from caking. That means they will not form a lump if we do the granulation. The fertilizer will not form a lump. Second one is the product friability. And the third one is the improve agrotechnical properties of the fertilizer. So these are the some of the reasons we need to do fertilizer granulation. Next question, what are the 5 mechanisms of interfacial bonding in agglomeration? What are the 5 mechanisms of interfacial bonding in agglomeration?
Van der Waals force, liquid bridge, solid bridge.
Yes. So, first one, then why particles agglomerate with each other? The reason being, first one is the Van der Waals force, which is an interparticle force. Second one is the force due to adsorbed liquid layers. Third one is liquid bridges. Fourth type of force is electrostatic force. If the particles are charged, then they can experience the electrostatic force. Fifth one is the solid bridges. So these are the 5 forces applying on particles to make them agglomerated. Next, the range of van der Waals force is small compared with that of chemical bonds. Is it true or false? The range of van der Waals force is small compared with that of chemical bonds. Is it true or false?
True.
No, it is false.
True.
So van der Waals force is large compared
Oh,
with that chemical bonds. Okay, so it is large. Next, so what is van der Waals force? So we can understand that it is the interparticle force. Suppose there are two particles, so they attract each other in some basis, and that is called van der Waals force. So suppose there is a term called
false.
Lennard-Jones potential. It is a distance versus potential curve. Okay. So what it says that the curve goes like this. So that means when the two particle distance is very less in this region, when the particles are in this region, they experience some kind of repulsion. Okay. So that is why this is the repulsion zone, and when the distance increases little bit, they experience attraction to each other. So this curve represents the attraction zone. So we always suppose we are bringing two particles very close to each other and we are thinking that the repulsion zone will come, but it will not happen because anything cannot come with that much close so that the repulsion will work. Okay, so anything cannot come. Suppose we are bringing our two hand palms together, but we are thinking it is clasped together, but it is not. Still, there is some kind of gap is there, which is not in the. That is why two particles cannot come in the repulsion zone. And always two particles or anything, two particles or two spheres, two any materials or subjects always remain in the attraction zone. So from here the van der Waals force starts. What is that? So van der Waals force is a summation of three types of force. First one is called the London dispersion force. Second one is the Hissam force, and third one is the Debye force. Okay, so what are these? So this part is not important. This is for your just knowledge what is called van der Waals force. Okay, so are you understanding what is van der Waals force I am telling?
Yes, ma'am.
Okay, so what is happened? Suppose there, so it is written the interaction between temporary dipoles and induced dipoles are known as London dispersion force. Temporary dipoles means suppose there is a particle which has some positive charge at the one side and electrons are traveling inside the particle. Electrons are always traveling, right? So suppose at some moment electrons are high in this region and electrons are low in this region. So what will they create? They will create a negative charge zone in this portion and positive charge zone in this side of a same particle. And suppose now we are bringing another particle which is non-polar. Okay, which is non-polar. So due to this previous first particle, this side is electronegative. So suppose due to presence of this electronegativity, this non-polar particle will experience some kind of charge on its surface, and it will be obviously a opposite one, right? So that will lead to delta plus in this side and delta minus in this side. Okay, but after some time it may happen that this portion becomes delta negative because electrons are always traveling. So at some moment, at some point it is in this region, at some point it may change their position. What will happen then? Then if it comes, if this side becomes delta negative and this side, then this side becomes delta positive. Similarly, for the non-polar particle also, this side will become negative and this side will be positive. So that is how they continuously two particles, which is a temporary dipole, and this particle is called induced dipole. The polar particle which is induced dipole, so it is called induced dipole, and this one is the temporary dipole. Dipole means it has two polarity. One side is plus and one side is minus. So temporary dipole. This one is temporary dipole. So if you can see focus on this picture. So what I will see that here it is temporary dipole. It is a minus sign is there and there is a plus sign. Similarly, it induces this particle This is minus plus. Similarly, it induces this particle opposite way. This is plus and minus. And this is how you can create a molecular distribution in a solid. So this type of force, the interactions between these temporary dipoles and the induced dipole are known as London dispersion force. Okay, this is the one type of dipole moment. Next is the permanent dipoles. So what is written? Some molecules are inherently polar due to their electronegativity difference between the constituent atoms. Right? So suppose water. Suppose water. So this portion is always negative and this side is always positive. This is the kind of permanent dipole. If two permanent dipoles react to each other, then it will lead to Kisam forces. That is why it is written that the dipole moment in such molecules is permanent. In a material, such dipole align themselves in a nose-to-tail fashion since the negative part of one dipole is attracted to the positive part of other dipole. So similarly, if we draw it, similarly water molecules are there. So this oxygen part is negative and hydrogen part is positive. So similarly, it will attract another particle, another water molecule where hydrogen portion will be this side and oxygen portion will be that side. Okay, so this interaction between two permanent dipoles lead to Kisam forces. Next comes the permanent dipole and induced dipole. So similarly here, this is permanent dipole and this is a non-polar molecule. And because of the presence of this permanent dipole, that is inducing charge on non-polar molecule, creating this sort of configuration. And this type of dipole is called the D-by forces. Okay. So now, if we sum all of this, things, this London dispersion force, Kisam force, and the Debye force, this will lead to the formation of van der Waals interactions between two particles or two materials. So this is the expression. Okay, so did you understand what is van der Waals force? A little bit idea. Did you get it? A little bit idea of what is van der Waals force?
Yes,
Okay, fine. So proceeding with our question. So now coming back to the lecture. So what are the forces appear due to the liquid bridges? What are the forces appear due to the liquid bridges? What are the forces applied due to liquid bridges?
surface tension and capillary pressure.
Yes, surface tension and capillary. Surface tension and capillary.
Perpendicular, annular.
That is the differences. So the capillary pressure and surface tension pressure will lead to liquid bridges. These are the forces applied, and there are different states depending on these liquid bridges are this pendular, funicular, then capillary and droplet phase. Okay, so these are the forces or its states, and its states appear due to the liquid bridges created between the two particles. These are the liquid bridges. Next question. Liquid to particle proportion is increased in pendular bridge. Is it true or false? Liquid to particle proportion is increased in pendular bridge. Is it true or false?
False.
Yes, it is false. So when in the funicular stage, or funicular bridge, liquid to particle ratio increases. Liquid to particle proportion increases. Next, mention the types of solid bridges. Mention the type of solid bridges.
Crystalline, liquid bridge,
Yeah. So first one is the crystalline bridge, then liquid binder bridge, and then solid binder bridge. Next, in which range adsorbed vapor forces are relevant? In which range adsorbed vapor forces are relevant?
below 80 micron.
80 micron.
Yes, below 80 micron. So there is a curve there, in the slides. So there are different types of what is the van der Waals range, then the adsorbed vapor force range, then liquid bridge range and solid bridge range are there. Next, mention the different size enlargement rate processes. Mention the different size enlargement rate processes. So there are almost 6-7 processes are there, that is compaction, then granulation, then agglomeration, encapsulation, pelletization or sintering, freeling, etc. So we will go through each type of videos. So this is the compaction. So in the compaction, you can see the product is feed is coming from here, and they are sent here, and now compact. It is getting compact between two forces, and it is getting some proper shape. So this is compaction. Okay. Next, so compaction means two forces are playing with each other on the substrate on your feed. Next one is the granulation. So these are the different steps of granulation. First milling will happen, then mixing, slugging, screening, and mixing with disintegrate, and last compression. So the whole process is the granulation. So first it is getting reduced in the Carter mill, the size of the particles. Then mixing is happening in the pre-granulation stage. Then slugging. So large particles are separated. In the screening also the particles are separated. Now lubricant is mixed to improve the quality. And lastly the compression. And it will create the granule, a single granule. Next one is the encapsulation. That means we are encapsulating the particles here. So this is how we encapsulate. Okay. Next one is the pelletizing. Next one is the pelletization. So pellet mill feeder. This is the feed particles are sent here and they are continuously being rotated with this machine. Now again it is rotated in variable speed. This is the shaft rotation speed and its RPM. So now here finally the pellets are formed. Okay. This is the pelletization process. Next is the agglomeration. So in agglomeration, assemblages are formed in a suspension and particles are dispersed and they are connected with other particles to make it agglomerated. So see, there are small particles and large particles. Now they are attached to each other or stick to each other. With the help of this water, gum, starches, and other hydrocolloids. This is called agglomeration. So in this real industry to see, so that is how it will happen. It will mix with the smaller particles, agglomerated, and they are separated. So you see the amount of agglomeration keep increases as the process proceeds. Next, this one is the extrusion process. So this is a real mill. So in extrusion process, some kind of force is given from outside, and that will create the enlarged of the granular particles. So you can see how is it moving and creating the pressure. Friction between the billet length and the container. And this the wall, there is the material. So this is how force is increased and it is creating the process, extrusion process. Okay, so this is the extrusion process. So here this happens at particular length of the extrusion, and the temperature is also needs to be maintained. Next is the sintering process. So this is the different type of base powder, alloy addition, and adhesiveness agent. First base powder is given, then alloy is added, then agent is added, adhesive agent is added. This thing happens and it is peeling, and now we are pressing it and creating a particular shape. It will go to the sintering process while heating from 800 degrees centigrade to 1250 degrees centigrade. Now the post-processing is happening. They are deburring and tumbling, and finally they are inside water. So this is the sintering process. Next one. Is the spray dryer. So here it is a rotator. Hot air is coming and it is spraying, and that is how it is get dried, the particles. So one side hot air is coming and another side cold air is passing to make it dry. This is one of the size enlargement process. Next is the prilling. So in industry, this is how prilling will happen. Prilling happens. So these are some of the interesting videos of size enlargement process. You can explore furthermore. Proceeding to the next question. So, on which properties excipients are dependent on? On which properties excipients are dependent upon? So, why in which properties on which properties excipients are dependent? That is the one first one is the drug used for the granulation. Second one is the process involved in granulation, like the processes we have just seen in the videos. Third one, the choice of excipients. Third one is the formulator. And fourth one is obviously the cost. Fourth one is obviously the cost of the experience. So these are some of the properties on which Experience are dependent upon. Next question. Name some bulking agents. Name some bulking agents.
Sugar, starch,
Yes, that is sugar, starch, lactose, then cellulose, dicalcium phosphate, etc. Next, these integrants are bulking agents. These integrants are one of the bulking agents. Is it true or false?
False.
Hmm. It is false because these integrants are considered as the functional additives. Next, give the examples of semi-synthetic and synthetic binders. Give the examples of semi-synthetic and synthetic binders. So there are different types of binders we have seen. Natural polymers, natural binders, synthetic, semi-synthetic, and other type of binders where alcohol and isopropyl alcohol chloroform comes. So semi-synthetic binders are some,
poly, polyethylene,
yes, then sodium carboxy methyl cellulose. Cellulose. Then ethyl cellulose. That is also one type of semi-synthetic binder. And in case of synthetic binder, that is polyethylene glycol. Okay, so you can remember this type of names because question may come from the what are the examples, or they may have give the MCQ type of question that choose between these four, what is the semi-synthetic. So you need to remember this. So this uh, call may end in 12 minutes. So I am creating a new link and share it in the chat. After, if this call ends, you can join there. Okay, just a minute. So I have shared the link. After 5 minutes, we will join this link. Okay. Or else now only we can join this. So Join this link and then I will end this chat and join that link. Are you getting?
Ma'am,
Yes, you join the other link. The link I have shared.
please share one.
It is in the chat box. Are you not able to see it? I have shared it again. See in the chat.
Oh,
Okay. Okay. So now we can continue. Next question. Jilan gum is a natural binder. Is it true or false? Jilan gum is a natural binder. Is it true or false?
True, ma'am.
Hmm. It is true. So other type of gums like hair gum, anacardium gum, these are also kind of natural binders. Next, what is used as a wet massing and fluid bed granulation? What is used as wet massing and fluid bed granulation? What material is used as a wet massing and fluid bed granulation? The answer is polyvinyl pyrrolidone. Polyvinyl pyrrolidone. Remember it. Next question. What is the difference between agglomeration and granulation? What is the difference between agglomeration and granulation? So, agglomeration, the video we have seen that the larger particles are going and it is going through a small heap of smaller particles and they are finally they are sticked with each other, right? So that is the mechanism of agglomeration. And but in case of granulation, the same things happen, but the mixing happens with the agitation. The mixing between or the agglomeration between these different type of particles will happen with a external force, that is the agitation, and then it is called the granulation. Otherwise agglomeration and granulation is kind of same, but there is a very fine difference between them, as the granulation is the agglomeration by agitation. Here in the granulation we need some external force. Next, explain the types of granulation.
dry granulation and wet granulation.
What?
Dry granulation and wet
Yes,
granulation.
yes.
Mixing.
So the main division is dry granulation and wet granulation. So in the dry granulation, mostly the solid particles are enlarged, and in the wet granulation, the particles inside the fluid, remaining inside the fluid, are getting enlarged. So that is why it is called wet granulation. So under the dry comes the dry mixing of particles, dry mixing, then slug, deslug. Third one is the compaction. And in wet granulation, first one is the aqueous and second one is the non-aqueous. Okay. Next, what is wet granulation process? What is wet granulation process? So we'll see the video.
Platinum, truly white.
So this is a wet granulation machine where it is fixed for the fluids are given, the feed is given, and then it is mixed continuously. Rotation is happening, and now it is taken out and it is going to fluid dryer. In the fluid dryer, due to the dry mixing, and finally it is collected from the bottom. Next, it goes into the advanced vibrosifter. And lastly, the octagonal blender. So how this will work, you can see in the inside video. So it is, the whole system is rotating here. The whole container is rotating. And finally it is collected from the bottom. So this is the wet granulation process. This is this is particular for this. Maybe this is the this company, but the general process is also similar, and people are using it with some modification. Next, what is drop controlled nucleation regime? What is drop controlled nucleation regime? So, suppose there are some powders and some droplet is there. Okay. So there are some other droplets also can be there. So its first condition is droplet should land on powder without touching the other one. Okay, so suppose this is the two droplets. So they should not touch each other. This one is the powder. This one is the first condition. Second one is the droplet should sink quickly into the powder. So when these two conditions are met, we can say that this is the droplet controlled nucleation regime. And it happens at low penetration time and low dimensionless spray. That means at low spray of the droplets can lead to the low rate of the spray of droplets can lead to the droplet controlled nucleation regime. Next, what is nucleation regime map? So there is a nucleation regime map from where droplet coalesce droplet generates that are shown there. So in the droplet controlled zone, so in the droplet controlled zone, you know that the nucleation occurs when one drop forms one nucleus and should occur when there is both. This happens, just I have said that this happens at a low spray flux and fast penetration time. Okay, so if we look into the graph, so what is the graph? This is a spray flux rate and this is the penetration time versus graph. So when that is very small, spray flux is very small and penetration time is also less, then this zone you can determine as drop controlled nucleation regime. Then comes the intermediate regime. Okay, then comes the intermediate regime. Here also it is 0.1, 1 and 10. So, and the top region in which region droplet penetration time is huge and caking also happens. This nucleation regime is called the mechanical dispersion regime. And in between these two, droplet control regime and the mechanical dispersion regime, there is intermediate regime. Okay. So this is the map or representation of the nucleation regime. Next question, which parameter signifies coalescence of droplets? Which parameter signifies coalescence of droplets? Which parameter signifies the coalescence of droplets?
Stokes number.
Yes, it is the Stokes number. So you can remember this formula. If some numerical comes, you will be able to solve. So this is the Stokes number, where rho is the density of the granules, v is the velocity of the granules, d is the diameter of the granules, and mu is the viscosity of the liquid droplet. So this signifies the coalescence of droplets, and it also depends on the critical value of Stokes number, that is also there. So the coalescence of droplets depends on the Stokes number. Next, when the granule size increase is roughly proportional to granulation time, that is called what? So when granule size increase is roughly proportional to granulation time. That means as time increases, the granule size also increases. So what is this?
Steady growth.
Yes, so this is called steady growth behavior of granules. And there is another one, that is induction growth behavior. Next, what are the mechanism of dry granulation? So the process of dry granulation depends on the interparticle interaction. Okay. So
Particle rearrangement.
yes, you know it, that particle rearrangement, then particle deformation, then they will be fragmented into smaller particles, that is fragmentation step. Fourth one is the now they have become smaller ones, so they will attract each other and create bonding. And finally, the plastic and elastic deformation. These are the 5 stages of dry granulation process. Next, a deformation that does not totally recover after the stress is released as plastic deformation or elastic deformation. That is true or false?
True.
Yes. So when the stress is relieved, so deformation, you know that, so suppose we are stressing something, and after we remove this stress, if the material does not recover its previous shape, that is called the plastic deformation. And oppositely, if it recovers its previous shape, that is called the elastic deformation. So here it is plastic deformation and it is true. Next, the product granule size of the fluidized bed. The product granule size of the fluidized bed. So for granulation, different types of equipments are used. Tumbling, mixer, centrifuge, right? So fluidized bed. So from the fluidized bed, what type of product we are getting? What size of product we are getting?
0.1 to
It is 0.1 to 2 millimeter range. Next, centrifugal granulators are used in chemical detergents. Is it true or false? Centrifugal type granulators are used in chemical detergents. Is it true or false?
false.
Because in for chemical detergents, stray granulators are used, and for centrifugal granulators are used in pharmaceutical companies. So centrifugal granulators are used in pharmaceuticals and agricultural well. Next, now I show you the different types of granulators. So first one is the fluidized bed one. So you can see that the fluidized bed granulation process involves suspending particles in an air stream, and that means air is coming from one side and another from another side. Granule particles are coming, and they are getting sprayed and suspended in an air stream and spraying a liquid from the top down onto the fluidized bed. Okay, so particles are sprayed from top. So this is how particles are attached with each other. And what is written? Particles in the path of the spray get slightly weighted and become stacky or sticky. The sticky particles collide with other particles, adhere to them to form a granule. So water, air is coming from bottom, and you are spraying something, and with the moisture, air moisture, that they are getting sticky, and they are attached to each other and create granules. This is the simple fluidized bed granule. Next is the mixer granule. So by mixing also we can create the granular. So what is happening? Solids are fed here. Different types of solids are fed from this top portion. Then they are mixed with each other. Okay, so they are mixing homogeneously. And there is also rotor and chopper. Now we are adding a liquid addition. Liquid addition by spraying. Okay. Either way you can add the liquid in the mixer granulator. And finally, this is the discharge process. So this is the mixing granulator. Previous one is the fluidized bed granulator. Last one is the centrifuge granulator. So in the centrifuge also the particles rotates and the surrounding axis, and they experience centrifugal force. and that is how they are attached with each other particle and creates granules. So you can see. So particles are sent and so high spinning is happening. Now the materials are released. So this is how a centrifuge granulator works. So now we will do some problems, and if you have any question you can ask from the assignment also.
Man,
Yes.
like in week 2 assignment, I have to post.
What?
In
Sir,
week 2 assignment,
Can you repeat it? I'm not able to figure it.
assignment 3 submit before 14 August. So
Yes.
few question will solve and few question is doubt. So please solve.
But it- Yes. Now tell me which question.
Sir, ma'am, question 1 is the answer is impact.
Yes.
Second question is answer is shape and size. These
Yes.
two questions are the previous assignment.
Okay.
And third one is which of the following is size reduction unit operation in liquids? This answer is homogenization.
Yes.
Fourth is soft material like ice can be crushed to smaller size by. This answer is hammer mill.
Yes. I don't know. Maybe hammer mill. I am not sure. It
Okay.
should be hammer mill actually.
Which among the following properties of the solid is not suitable for designing equipment? My answer: moisture, oil, and fat contents.
Suitable for design. Color improvement is also common. Which among the following properties of the solid is not suitable for design improvement? I think color. I don't know, but my instinct is color improvement.
Color. Okay.
Maybe you might also might be right.
Next, length is critical of a concrete. This answer is 0.177.
Yeah, if it is coming, then it is fine.
Name 1, 2, 3, and 4 question doubts. So please solve.
Which one?
Next question 1, 2, 3, and 4th questions are doubts.
7, 8, 9, 10.
Yes.
Yes. Why? Why is it? Because it is the. I think it is the size reduction problem, no? Why is it?
Yes.
Doubt? Where is the problem? Tell me.
Why what factor will be stress field change if the crack length increase by 4 times and
Hmm.
the distance from the crack tip do not change?
Hmm. So there is a formula.
Yes.
Hmm, just a minute. So there is a formula of stress intensity factor. Okay. Just, stress intensity factor means, so there is a relation is stress intensity factor, which can be calculated like this. K is the stress intensity factor. This is sigma root under pi and A. Here sigma is the stress, applied stress, and A is the crack length, that like for what stress the crack length opens up. Okay. So this is the formula. So now I think you will be able to do it because everything is given. In the question it is said that by what factor will the stress field change if the crack length increases by 4 times and the distance from the crack tip do not change. So it is said that the crack length increases 4 times, right? So what will happen in the second case? Suppose in the second case, stress intensity factor is K prime and the stress applied is same, that is sigma only, and under the root this is pi, but here it is said the crack length increases by 4 times, right? So we are writing it as 4a, right? We can write it like, right? Are you getting? Yes, no?
Yes, ma'am.
Yeah.
Yes.
So here it is said that the crack length is getting increased by 4 times. So we are writing it as 4a. Now you will simplify. What will happen? So it will come sigma root under 4 pi a and it will lead to 2 sigma root pi a, and sigma root pi a is nothing but the stress intensity factor, that is K. So in the question, by what factor will the stress field change? It will be 2. Option
Okay. Thank you.
A. Okay. Now in the number 8 question, what is the problem?
Please solve. I am solved but not sure.
How you solve it? How you solved it?
Uh, efficiency size reduction eta is equal to epsilon
Hmm.
ASP minus ASF upon WS.
Uh, it will apply the Rittinger's law experiments formula. Okay, so what was Rittinger's law experiment? Rittinger's law formula, that is work done will be proportional to the understand. Yes, so work done will be proportional to its surface area change. It is the surface area of the product and surface area of the feed, right?
Yes, ma'am.
Yes. So now what is the surface area? It is not mentioned. It is only the diameters are mentioned. So we can calculate the surface area. First, we will see that what is the product. It is said the equivalent size, spherical size is 75 millimeter. And after the reduction, it is found that the average size of the particle is 7 millimeter. Right?
Yes, ma'am.
And now this density of the particles is also given. So from there only and from the mass also we can calculate the number of particles. So what is number of particles? Suppose last week I have said that suppose there is a single particle. It has diameter dp, and so what will be its volume? That will be 4/3 pi dp by 2 whole cube, right? Now,
Yes,
the total mass of the particle, suppose these type of limestone particles are multiple in the container. So this is I have said for one particle. So for total mass of the particles, if it is m, then we can calculate the how many numbers of particles are there. So how many particles are there in this container we can calculate if we know the individual particle density and the total mass, right? So how we'll calculate? This is mass of the total particles divided by the volume, that is each particle volume, and their each particle density, right? This is the total
Yes.
mass, and this is for the individual particle, and this is how we can calculate the how many number of particles are there. So in this case, what will happen? For the mass is 2 kg, right? For mass is 2 kg, limestone density is 2709,
Yes, ma'am.
and for feet particle, the diameter is 75 millimeter. So
Yes, ma'am.
it's 75 millimeter. That means if we convert it in meter, it will be 0.075, right? 0.075 by 2 whole cube,
Yes, ma'am.
right? So number of feet particle we can calculate from here. How much is it coming? Can you calculate? How much is it? So you calculate and check, but it is 3.34. 344 almost. This is the number of feet particles. Okay. Similarly, we are calculating number of product particles. Similarly, only the diameter will change here. So kg will be same, total mass will be same, the density of particles will be same, and only this will change. What is the product size diameter? it is 7 millimeter. So that
So,
will be 0.007 by 2 whole cube, right?
yes, ma'am.
And how much N2 is coming? It is coming almost 4113, 4112.9 number of particles. So it is very big number of product particle is very big, obviously, because in the Oettinger's law only it is stated that the surface area will be increased in case of Oettinger's law when the particle size will be reduced. So now we have got the N1, N2. N1 is the number of feed particles, N2 is the number of product particles. Now we will calculate the surface area. So it is the feed surface area. Total feed surface area. This is the total feed surface area. What will come? N1 is the number of particles and similarly the single surface area of the particle. So what is N1 is 3.344 and single feed particle size is 0.075 whole square, right? Yes. So now calculate what it is. So we'll get the total surface area of the total all the feed particles, and it will come at 0.059 meter square, right? Approximately. Are you getting?
Yes, ma'am.
Similarly, what will be the product particle size? Calculate and tell me. Product particle surface area. Similarly, you calculate. N2 is how much was N2? 4112.9. That is 4112.9 into pi d2 square. D2 here is the product size particle. That is 0.007 whole square. So how much is it coming? Tell me. How much? Tell me. This is just a simple multiplication.
0.633.
0.63, then 28.
Yes.
Yes. So this is the product particle surface area. Now everything is there. We have to calculate the what we have to calculate. We have to calculate the this energy.
Yes.
We have to calculate the energy. So from Rittinger's law, we are calculating the energy. So as per the formula, that is AP minus AF. So Kr is given, right? What is the value of Kr? Kr is 0.250 joule per meter square. 0.25 joule per meter square, and this is 0.6328 minus 0.059. So it is coming as it is coming as 0.1434 joule, right? Now another thing is given, that is the efficiency is given. So it is said the reduction efficiency is 0.85. So actual efficiency will be greater than that. So actual efficiency is 0.1434 joule divided by 0.85. Now it is 0.1687 joule. This is joule. But in the question it is asked that energy absorbed by the material per kg. So we have considered 2 kg of the material, right?
Yes, sir.
Yes. So now we have to divide the whole things for doing it per kg. So same things will be divided by, so it is efficiency per kg. So it will be energy, not energy, this energy, answer is energy per kg will be the 0.1687 by 2, that is 0.0844 joule per kg. So the answer will be this one, C. Did you get it?
Yes, ma'am. Yes.
Okay. So this way you have to calculate the size reduction problem. Anything else?
Okay, ma'am. Thank you.
Okay.
Ma'am, like I have doubt in the week 2 assignment.
Yes. Tell.
Means in week 2, once can you open the week 2, ma'am?
Week 2. Okay. Yes.
Like can you scroll down like
Yes.
like 8th question I had doubt. Eight.
Number 8.
Yeah, ma'am. Like I got the answer like yeah, ma'am, but it's given reverse of that.
The crushing efficiency is defined as the ratio of surface energy created by crushing to the energy absorbed by the solid. The ratio of energy absorbed by the solid to that fed to the machine. The ratio energy fed to the machine to the surface energy created by crushing. The ratio of energy absorbed by the solid to the surface energy created by the crushing. So what was your question?
Means like they given option D, ma'am, but the answer is like A. It should be A, no, ma'am. It's the ratio of energy created by energy absorbed.
Energy
they given,
created by energy absorbed. Yes. Yes.
so it's like they give.
Yes. So it should be the output versus input.
Yeah, ma'am.
Yeah, so energy created should be the top one. Energy given. Yeah. Yes, you are right. Maybe they have given wrong. So it will not happen in the exam, I think. So it,
Like this will be added now, ma'am. So will the correction will be done or
correction will be done or not. I don't know because then you can mail in the NPTEL discussion forum, but it is not in my hand. I cannot tell them to correct it. So they have
means
floated
in
the
this?
question.
So I have to do in the discussion form one, ma'am.
If you want, because but I will tell that don't need to raise the question because it is they have mistaken it. It will not happen in
Yeah,
the
ma'am.
final exam. So that is important. This assignment is just to check. So
No, ma'am, but no, that like, but
huh.
this will be added to this, no, ma'am. Score will be added, no, ma'am. Fine.
Okay, score will be added. So then you can mail them. Yeah.
Means in the form I have to do this,
Yes,
right?
yes. In the form, you can raise the issue.
And the fifth question, like
Hmm?
fifth question.
Fifth question. Yes.
Yeah, here like they asked a wrong statement, no, ma'am. That, but
Yes.
it's like that they gave D option, but it's like correct only, no, ma'am. Like screens are like stationary, vibratory, no, ma'am.
Pick out the wrong statement. Magnetic separation method can be employed to treat both dry and wet tools. Reduction ratio is crushing operation. In crushing operation is defined as the ratio of minimum feed size to maximum product size. Gyratory crusher is used for coarse crushing. Screens are stationary, moving, and vibratory types. What was your answer?
Mine is like I kept like B, ma'am. Like its reduction ratio is like a normal feed to the product, no, ma'am. But
Reduction ratio is feed to the product size. I I think.
yeah, yeah, ma'am. Yeah, ma'am. But like they gave D option, but it's like it's correct only, no, ma'am. D option. It's like screens are stationary, moving, and vibratory. That kinds of screens.
Uh, screens generally are stationary and vibratory types. Moving screens, I don't know, maybe there, but it seems it is a moving screens is very not very normal. I think stationary and vibratory can be said true, but moving screens, I think it is wrong. It is wrong. I think.
It's okay, ma'am.
Hmm. Any
Yeah,
other
like
question?
this. Yeah, like these two questions. And like, ma'am, can you come to this week one assignment? Like
Yes, week one. Yeah.
week.
Hmm.
Yeah, like the first one, like first question, like
Hmm.
it will also include like machine operations also, no, ma'am. Means
Which of the following explains mechanical operations correctly? This is science and technology, particular intent, machine operation, particular method,
so like machine operations will also be included or not?
Hmm. Mechanical operation is all mainly about the particles we are talking about. We are not focusing on the machines. We are using machines to reduce the size and enlarge the size. We are using different kind of machines, obviously. But I think the way they have given the answers, the options, it seems like the mechanical operation is mostly talking about the particles, the particulate matter. It's not the focusing on the machine equipment.
Ma'am, but we are calculating the power of the machine, power
Yes,
consumed.
yes, yes. We are calculating machine operations for the particulate matter. Na after for size reduction of this particulate matter, how much power is required? That is why. Yes, C also can be correct, I think, but they have given A.
Yeah, ma'am.
Hmm.
That's what. So like
Any?
these three, like I got one. That's what I had doubts.
Okay, okay, that is fine. Anything else?
That's all, ma'am. Like in this only, like
Hmm.
in week one, wait. Let me see. Yeah. Like eighth question, ma'am, in week one.
Hmm.
Well, yeah. The answer is like given. It's like the given B option, but it's the D means like star mentioned in lecture. It's 0.75 ma'am. 0.0075 centimeter.
Okay. Is it coming 0075?
Yeah, ma'am.
In the in the SAS lecture it is written.
Centimeter. Yes.
0075 centimeter it is written.
Yeah, ma'am.
Okay, okay.
It is.
Oh, then I don't know. They have it
Yeah.
is all mistake from their part.
Yeah, ma'am. Means actually this will be included in our grades, ma'am. That's the point.
You can raise these questions which you are very confident enough, like this one. If it is written in the slide, then it should not be. It should be
Yeah.
right one. So you can raise these questions in the form.
Yeah. Like in week two, that
Yes, yes. In the week two also. Okay. Anything else? Question?
ज्वाइनिंग अपना टाइम होगा अभी
No, ma'am. Okay, thank you.
Okay. Okay. Okay.
yeah,
Fine.
nothing.
Okay.
Like this I have to do the question based on this discussion one, ma'am. Question
Yes.
forum.
Discussion forum.
So, okay.
Yeah.
Okay, ma'am.
Okay. Sure.
Okay, ma'am. Thank you.
Yes. Yes. Thank you.
Can I?
Yes. Yes. Sure. Sure. So today we can do the last sum about this Higgs law, right? So last day we have not done any problems on the Higgs law, so we can do it today. So there is a question. So there is the question is a sample material is crushed in a jaw crusher such that the average size of particles is reduced from 50 millimeter to 10 millimeter with the energy consumption of 13 kilowatt second per kg. Determine the consumption of energy to crush the same material of 75 millimeter average size to 25 millimeter using Rittinger's and Hicks law. Okay. So what is said? Both the cases, Rittinger's law and Hicks law, needs to be applied. So we are doing first the Rittinger's law. So Rittinger's law is work required is Kr 1 by product diameter minus 1 by feed diameter. So energy consumption is set 13. 13. Then we don't know the Kr and product size is 10 millimeter minus 50 millimeter. Or in meter also you can convert it. 10 millimeter means 0.001 millimeter. 0.01 millimeter and this one is 0.05 millimeter. So how much the Kr is coming? It is Kr is 0.1625. The unit will be kilowatt second by kg meter, right? So in the second half of the question, it is asked that in the same machine, if the particle size to be reduced from 75 millimeter to 25 millimeter, what will be the energy consumption? So following the similar law, now we have to calculate the energy consumption, that is Kr we know 0.1625. This is not meter, will be in the top. Okay. So kilowatt second meter per kg. So it will be 0.1625 into 1 by 0.025 meter minus 1 by 0.075 meter, because here the feed size is 75 millimeter and the product size is 25 millimeter. Now the energy consumption will be energy consumption will be 4.33 kilowatt second per kg. Okay, and it can be converted into so now you have to change it in ton and hour. So we have to divide it by 3600 because 1 hour equals to 3600 second, and we have to, and 1 ton equals to 10 cube kg. So we have to multiply it with kg, with 10 cube. That will be 1.203 kilowatt hour per ton. Okay. Next, we will do the same problem with the Kick's law. So what will come? So in the Kick's law, the energy consumption is Kk ln ratio of feed diameter by ratio of product diameter. So initially we know it is 13 kilowatt second per kg equals to Kk, and ln will be, so initially the diameter was 50 millimeter and 10 millimeter. So finally the Kk will come as 8.077 kilowatt second per kg. The next half of the question, it will be the energy consumption which we have to calculate. It will be Kk is 8.077 kilowatt second per kg, and ln will be 75 millimeter by 25 millimeter, and it will lead to 8.87 kilowatt second per kg. Similarly, you have to transfer it in hour. That is 2.46 kilowatt hour per ton. So this is the example of Fick's law and Rittinger's law size reduction. Next one problem we can do. About the roll mill roll diameter. So the question is, a pair of rolls. I have explained the derivation in last class. A pair of roll is to take a feed equivalent to sphere of 3 centimeter and crush them to sphere of 1 centimeter diameter. If the coefficient of friction is 0.29, what could be the diameter of rolls? Okay, so in yesterday I have in early week class I have derived all the details of the roll diameter and what equations are used. So from there we can calculate it. So mu is the coefficient of friction, that, and mu, we have remembered that mu is tan alpha, right? So alpha is tan inverse of mu. So mu is coefficient of friction, mu is coefficient of friction, and alpha is the angle of knee, right? So what will be the value of alpha? So alpha will be tan inverse 0.29, that is nothing but 16.17 degree. Right, now we have got the angle of knee. So we have remembered the formula of cos angle of knee, that is cos alpha equals to feet diameter, not feet diameter, it is the diameter of the roll, that is R1, plus product diameter, that is R3, similarly R1 plus R2. R1 is the roll diameter, R2 is the feet diameter, feet particle diameter, and R3 is the product or crushed particle diameter. So we know every value. So cos 16.17 degree equals to R1 plus crushed diameter is 1 centimeter, or we are using the diameter here only in R3, place of R3, because we are taking the ratio of two types of diameter, right? So if we take diameter, radius, it doesn't matter, but if you confuse, you can write it as 0.1 centimeter, right? So it will be 0.5 centimeter divided by R1 by the feet diameter is 3 centimeter, that will be 1.5 centimeter. So now we can easily calculate the R1. What will it come? So it will be 0.96 equals to R1 plus 0.5 by R1 plus 1.5. So it will be 0.96 R1 plus 1.44 equals to R1 plus 0.5. So now R1 will be 23.5 centimeter. This is the roll radius, and roll diameter will be multiplied by 2. 23.5 into 2, that is 47 centimeter. This is the answer. Okay. So go through the sum and go through the assignment problem I have done in this class, and go through the whole lecture, and obviously the sir slides is very important to answer the questions. And still, if you have any doubt, raise a question in the discussion forum. Until then, thank you and goodbye.